Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video again we are going to solve a question that was asked in JAM 2024 chemistry paper. That is again based on the Laporte selection rule. Okay, what is the question? The DD transitions in manganese hexa aqua complex and a titanium tetra aqua complex respectively are ignore spin orbit coupling and John-Teller distortion. Okay, so the question is about the whether it is symmetry allowed or symmetry forbidden transitions. Okay, that is what we saw just now. It is based on the Laporte selection rule. What does the Laporte selection rule states? It states that the delta L, that is change in the azimuthal quantum number delta L, should be plus or minus 1. Okay, so if you see a p orbital is what? Phase is opposite. Okay, so if you consider this point, if you go up, here it is a positive phase. If you go down, it is a negative phase. So this point is not a center of symmetry. Not a center of symmetry. But if you see, this was a p orbital. Now, if you see a d orbital has a, it is a 4-lobe orbital. Okay, d orbital. It is a double dumbbell shape. So here what happens is the phases are opposite, lobes have the same phase. So if I consider this point again, okay, here if I go to this lobe, it is negative phase. Exactly opposite if I go, I get the same phase. Similarly here if I go, I get a positive phase. On the exact opposite side, I get a negative phase. So on the opposite side, we are getting the same phase. So this is called as a center of symmetry. Okay, and wherever center of symmetry is present, those orbitals are what they are called as geared. Okay, they are geared, and the one where there is no center of symmetry, they are called as ungeared. So mostly for the octahedral complexes, okay, this Laporte selection rule is applicable for the octahedral complexes where there is center of symmetry is present. Okay, center of symmetry is present. Okay, center of symmetry is present because here d orbital is involved, as we saw just now. There is center of symmetry that is present. So these are called as centrosymmetric complex. Centrosymmetric. Okay, octahedral complex. Okay, this is centrosymmetric in nature. Okay, so what will be s orbital? S orbital, again you can see s orbital has got one single phase, so it is geared. P orbital we saw just now, it is ungeared. D orbital is geared. So geared to ungeared, this is what? This is allowed transition. Okay, geared to ungeared, it is allowed transition, and geared to geared, it is forbidden transition. Why? Geared to ungeared, that means let's say S to P. Okay, geared to ungeared, S to P. For S, what is the value of L? It is 0, and for this it is 1. So 1 minus 0 is plus 1. So delta L is what? Plus 1. So delta L is what? Plus 1. That is a allowed transition. Okay, but geared to geared, for example, DD transition. Okay, DD transition. D orbital we saw just now, it has a center of symmetry, so it is geared. So geared to geared, that is a DD transition. It is what? Delta L is 0. So it is what? It is a spin forbidden, it is a Laporte forbidden transition. Okay, this is for a octahedral complex where center of symmetry is present. But what happens in case of a tetrahedral complex is, a tetrahedral complex, what happens is hybridization is sp3. So there is a p orbital that is involved. So in tetrahedral complexes, what happens is, in a tetrahedral complex, what happens is there is a pd mixing. Okay, initially there are 2 d orbitals. Okay, there are 5 degenerate d orbitals, and in an octahedral field it splits into T2G and EG. So this is purely d orbital, this is also purely d orbital. So d to d, this is forbidden transition. Why? Because delta L is 0. But what happens in case of a tetrahedral complex is, in tetrahedral complexes, there is a PD mixing. Okay, there is a mixing of p and d orbital. So what happens is, the transition is not purely d to d. This d orbital has some p character, some p character. So we saw just now, p to d, they are what? They are allowed transition. P to d is a allowed transition. P is what? P is unjared and d is jared. Unjared to jared is a allowed transition. So if the d orbital, okay, has got some p, some character of the p, so what will happen is, this is what this is, we can say that it is a partly allowed Laporte transition. Okay, partly allowed Laporte rule. So in case of tetrahedral complexes, what will happen is, in there are two complexes that are given to us. One is manganese H2O6 2 plus. Here it will be what? It will be Laporte forbidden, or we can say symmetry forbidden transition. Symmetry forbidden DD transition. But for tetrahedral complex, that is Ti, okay, H2O 4 3 plus, this is the tetrahedral complexes. Here we can say it is Laporte allowed, okay, or symmetry allowed. It is a symmetry allowed transition, because here what happens is, here there is no center of symmetry that is present. Okay, in a molecule with non-centrosymmetric is tetrahedral. Why it is called non-centrosymmetric? Because this is the basic structure of a tetrahedral complex, right? Here there will be a metal, okay, and then there are 4 ligands. So if you see here suppose there is some ligand on the exactly opposite side, can you see any ligand? No. Okay, similarly here, if there is one ligand exactly opposite, if you see, is there any ligand? No. So there is no center of symmetry present in a octahedral complex. That is what is called non-centrosymmetric. There is PD mixing that can occur to a great extent. So what happens? Probability of it, the probability of the symmetry, it is a Laporte or symmetry forbidden. Okay, why it is symmetry forbidden? We saw just now, DD transitions are Laporte forbidden because the delta L is equal to 0. It does not follow Laporte selection rule. Okay, according to Laporte selection rule, delta L should be plus or minus 1. Okay, but in case of octahedral complexes like titanium, tetra, aqua, 3 plus, so what happens here? It is, there is some relaxation of the Laporte rule. Okay, so that is why it is a Laporte or symmetry allowed transition. Symmetry allowed transition because of the PD mixing. Okay, so first one is what? Laporte forbidden, that is symmetry forbidden. Second one is symmetry allowed. So the correct answer is what? Correct answer is option B. Okay, the correct answer will be option B. I hope you have understood how what is Laporte selection rule and how there is relaxation of the Laporte rule, that is, it is partly allowed. Okay, relaxation in the Laporte selection rule for tetrahedral complexes. Okay, because of the PD mixing. Okay, the correct final answer is option B. I hope you have understood this solution. Thank you.